Have you ever looked up at the night sky and wondered, where did it all come from? The galaxies, the stars, the planets, even you. What if I told you that everything you see today, every atom, every particle, was once compressed into a single point smaller than an atom? This is the story of the Big Bang, the most mind-blowing theory about the origin of our universe. In an instant, space itself expanded faster than the speed of light. This wasn't an explosion in space. It was an explosion of space. At first, the universe was pure energy, but as it cooled, the first subatomic particles, quarks, electrons, began to form. As the universe cooled further, quarks combined to form protons and neutrons, the essential building blocks of atoms. After 380,000 years, electrons finally joined with protons and neutrons, forming the first true atoms, mostly hydrogen and helium. With atoms formed, light was finally able to travel freely, creating what we now see as the cosmic microwave background. For millions of years, the universe remained dark. There were no stars, only vast clouds of gas waiting to ignite. Gravity pulled gas together into dense clumps, and after millions of years, the first stars were born in fiery bursts of nuclear fusion. Over hundreds of millions of years, gravity pulled stars together to form the first galaxies. Invisible yet powerful, dark matter shaped the universe by holding galaxies together. Galaxies linked together in vast structures, forming a cosmic web stretching across the universe. At the heart of galaxies, supermassive black holes began forming, shaping their evolution. One of these galaxies was the Milky Way, our future cosmic home. As galaxies formed, some regions of space were filled with chaotic clouds of gas and dust, swirling under the force of gravity. Around 4.6 billion years ago, a massive cloud of gas and dust collapsed under its own gravity, igniting nuclear fusion. Our sun was born. As the sun settled into stability, leftover material clumped together, forming the first planetesimals, building blocks of planets. Earth began as a molten world, bombarded by asteroids and comets, gradually cooling to form the first crust and oceans. A collision between Earth and a Mars-sized body led to the formation of the Moon, changing Earth's future forever. In Earth's early oceans, chemicals combined under the right conditions, forming the first simple organic molecules. Around 3.5 billion years ago, the first single-celled organisms appeared, evolving in Earth's waters. Some of these microbes evolved to use sunlight, creating oxygen as a byproduct, changing Earth's atmosphere forever. About 540 million years ago, life exploded in diversity. Complex organisms, shells, and the first predators appeared. From tiny reptiles to towering giants, dinosaurs ruled Earth for over 150 million years. 66 million years ago, a massive asteroid struck Earth, causing wildfires, tsunamis, and blocking out the sun. This event marked the end of the dinosaurs. With the dinosaurs gone, mammals rapidly evolved to fill the empty ecological niches, leading to the rise of new species. Among these mammals, primates began to evolve, developing better vision, grasping hands, and larger brains. A few million years ago, some primates evolved into early hominins, our direct ancestors, marking the beginning of human evolution. 200,000 years ago, Homo sapiens appeared, equipped with intelligence, creativity, and the ability to shape their environment. Around 10,000 years ago, humans transitioned from hunter-gatherers to farming societies, leading to permanent settlements. With agriculture came cities, writing, and culture. The great civilizations of Mesopotamia, Egypt, and China began to rise. From Galileo to Newton, humanity's understanding of the universe expanded dramatically during the scientific revolution. The 18th and 19th centuries saw incredible technological progress, from steam engines to electricity, shaping the modern world. In the 20th century, humans broke the bounds of Earth, launching satellites and eventually landing on the Moon. As humanity explores Mars and beyond, we begin to take our first steps into a multi-planetary future. The universe continues to expand at an accelerating rate, but what will happen in the distant future? One possibility is that stars will eventually burn out, leaving a cold, dark, lifeless universe. Some theories suggest that dark energy might tear everything apart, including atoms themselves. Could gravity eventually reverse the expansion, pulling everything back into a singularity, leading to another Big Bang? Could our universe be a simulation? Some scientists believe advanced civilizations might create simulated realities. Are we part of a vast multiverse? The idea suggests countless parallel universes may exist beyond our own. As technology advances, human consciousness may merge with AI, leading to an era of superintelligence. Will we become an intergalactic species? Could we one day colonize distant exoplanets? With billions of planets in the universe, are we alone? Scientists continue searching for signs of life beyond Earth. If the universe continues to expand indefinitely, galaxies will drift apart, and all sources of light and heat will eventually fade into darkness. Eventually, entropy will reach its maximum, and the universe will become a cold, lifeless expanse where no energy can be harnessed. Some physicists suggest that quantum fluctuations could trigger the birth of a new universe, restarting the cosmic cycle. Over trillions of years, even black holes will evaporate due to Hawking radiation, leaving behind a universe without structure. Will the universe remain in eternal darkness, or could new physics allow for a cosmic rebirth? The story of the universe may never truly end.